Okay, spreadsheet. I put in the spreadsheet some calculations for transient, frequency, and period. And as we know, they are reciprocals of each other. So if you put in a value for the frequency in hertz, the spreadsheet will calculate the period for you in seconds. And you put it in the blank square there. So if I use 50 hertz and I enter it, it tells me that I've got 0.02 seconds is the period of that waveform. Then I can move my decimal and add a engineering prefix, and that would be 20 milliseconds. I've also, for SPICE purposes, it asks me what my sampling needs to be, which is, I use a tenth. It's easy to remember, so I've got that calculated there, and if I want to do 3 times the period, it multiplies. So now let's go to an LTSpice circuit, and we will set up 2 AC values of different frequencies, and I can recycle one from a previous video. Now, in order to do transient, I have to go in and set up a sine wave. I need to do a video on doing a square wave and a triangle wave, just making that waveform, because you gotta do some things to set up there as well. And I will probably do a video to show that. So, for my sine wave, I can put in my amplitude, and it does need to be the amplitude. And I put in my frequency. I'm using 50 hertz. And then, when SPICE does its thing, I need to tell it how many cycles I want. Now, we're going to display a window, and usually we display 3 cycles. So your number of cycles should be more than what you're going to display. And if you have 2 frequencies for different waveforms, you've got to think about which one is the longer period. And so you always want to set your analysis up for the longer period or the lowest frequency. Alright, so once I do that, now I've got that voltage source back as a sine, and you can go in and you can edit those directly, or you can go back into the window and make changes if you can remember what everything means. I'm going to go to the other one, do the same thing. I'm going to make it a sine wave. I'm going to put in the amplitude, and 12 volts RMS is 17 volts amplitude. Frequency is 100. Number of cycles. Now if your frequency goes up, your period goes down, so you'll need more cycles actually. So I put in 9. Again, you want to make sure this, whatever you display, you capture. And if you don't, you just go back and change it. It's not that big a deal. And there is the sine wave. So I'm going to cut out the dot op. I'm going to cut out that AC analysis, so I can go in and set up my transient. And transient's the default. We need to know the stop time. So if we're in an AC circuit, our stop time can be from the start time, the interval from the start time that we want to see. So we can often use a 0 in a DC circuit. If we have reactive components, we'll want to skip a cycle or two and then start taking data. So again, this is not going to make it work or not work. It's just understanding. With a DC circuit, I can start at 0, and my period is 2. If I want to capture 3 cycles, I need 3 times that. And I went ahead and converted those to milliseconds because Spice will recognize it. So 60 milliseconds. So I'm going to capture from 0 to 60 milliseconds of the sine wave. And my max time per step is going to be that 2. And there's my sampling. That is 2 milliseconds. When we do the, when I do the video on setting up triangle and square waves, I'll add to the spreadsheet, and I will post the spreadsheet. Sometimes with reactive components you check these depending on what you see, but usually you can just start them out as unchecked. So there's my transient, and now I can simulate it. Now when you simulate it, it's going to open a window just like what you see on oscilloscope, and it happens to open all the windows of all the circuits I've got. So I've got to close those and get back to just the 2 that I'm interested in. And if I want to look at the voltage on V1, I would click there, and there's my voltage. As you see, it's 7 volts peak, minus 7 volts. And the time should be about 20 milliseconds between peaks or valleys or whatever, however your reference is. And that looks about right. I'm sampling it 10 times, so it looks good. Now I clicked on the other one, so I show V2, and what you see is that the frequency is doubled. And then I clicked on the voltage at point 2 or node 2, and it is showing me the voltage drop, showing me what's going to happen. And basically what you get is you get a mixture of the voltages of the 2 incoming waveforms. And then you've got drops across the resistors, which knocks it down. So you get the 3 voltages for the 3 nodes. You can see what they are. They're not a true sum because of the resistors, but you can definitely see that one affects the other. I'm going to go in and change the frequency now. And anytime you make a change, you got to rerun it. Now everything's at 50. So both waveforms are at 50. So you could look at it, same frequency. On transient, you can see what you got. And I can make the 50, the 7 volt, 100 hertz. Okay. And then run it, and then you see that I get another variation. Now my 7 volt is the more frequent. So once you get a circuit in there, going in there to make changes is pretty straightforward. I would suggest that you do some of this to get more used to it. Nothing's hard. And if you got a question, you're not sure, you can email me and ask. But this is very powerful software. It gives you can sort of simulate so much so quick, and you can see how the circuit reacts. And if you do a circuit that you could physically build, then you could look at the waveform on the oscilloscope as well. And we'll do some of that at some point. If you want to see the currents, it'll show you the currents. And there's the current through V1 showing you what it's doing if you want to see the currents. So current is hover over, voltage is touch the node above, and I thank you for watching.